Hello and welcome in this math video lesson. Today we're going to talk about simplifying rational expressions and restrictions on variables and what that means. So let's just start with an example, shall we? There we go. 3p to the power of 3 times c to the power of 4, all divided by 5c to the power of 5, and this is what we want to divide by 24p to the power of 5 times c over 10 times c to the power of 3. How do we do this? Well, remember that division by a fraction is the same as multiplying by the opposite fraction. What do I mean with opposite fraction? Well, we just flip the top and the bottom. So how do we do this? Well, as follows. This is equal to, the first part we just leave it as it is. 3p to the power of 3, c to the power of 4, all over 5c to the power of 5. And now, like I said, we change division into multiplication. So this division symbol over here turns into multiplication symbol. And remember, flip. So we get 10c to the power of 3 all over 24p to the power of 5c. Well, look at that. This is something we know how to work with, because multiplication with fraction is easy. We just multiply the top and we multiply the bottom. So we get 3 times p to the power of 3 times c to the power of 4 times 10 times c to the power of 3. Remember, multiply the numbers first. 3 times 10 is 30. Multiply the variables. So we get p to the power of 3 and c to the power of 4 times c to the power of 3. Remember, we multiply variables so the powers get added. This becomes 4 plus 3, 7. And this we divide by, we do the same process on the bottom. 5 times 24, 120. C to the power of 5 times p to the power of 5 times c. Remember, there's a small hidden 1 if there is no given power. So we get c to the power of 5 plus 1 is 6 times p to the power of 5. And now what do we have to end with? Well, we have to simplify as much as we can. And hopefully you see that 30 and 120 share what number? Well, since it's a video, there is no interaction, but hopefully you would have been screaming 30 at your screen, because indeed 120 and 30 can both be divided by 30. So this is just 1 over 4. And what do we do with the p's and the c's? Well, p to the power of 3 and p to the power of 5, we can both divide them by p to the power of 3. So we end up with nothing for p on the top, and we end up with p to the power of 2 on the bottom. Again, we divide by p to the power of 3, so we subtract 3 powers from 5 powers. And with c we do the same. C to the power of 7 divided by c to the power of 6 is c to the power of 1. So that's just c. So what we end up with, we can simplify this a bit. No c to the power of 1, but we can write this as just c, because 1 times something doesn't really change it, divided by 4p squared. And now the interesting thing comes into play, because as you might remember, the title was not just simplifying rational expressions, it's also restrictions on variables. What restrictions do we have? Well, let's have a look at the initial question. We were working with fractions, and you probably know since a few years back that division by 0 is the unholy act of mathematics. You cannot divide by 0, and we don't want you to do that. So what do we need to keep in mind? Well, these are fractions, so basically these are divisions. So since we do not want you to divide by 0, 5c to the power of 5 is not allowed to be 0 because this is a division. And for the same reason, 10c to the power of 3 is not allowed to be 0 because this is also a division. Alright, so what does that tell you for c? Well, if 5c to the power of 5 cannot be 0, the only value that c cannot have is 0 itself, because 0 to the power of 5 would still be 0 times 5 would still be 0. And the same holds for 10 times c to the power of 3. So here we know c cannot be, and we do that with the equal sign with a slash through it, 0. Is there any other restriction, you might ask? Well, yes. This entire thing is something we're dividing by, as you can see by this symbol. So 24 times p to the power of 5 times c also should not be 0. Or at least, what's the result of this thing? Well, in that case, p can not be 0 either. Because if p were to be 0, this whole thing would become 0. This fraction would be 0 and we would be dividing by 0, which is not allowed. So our solution is c over 4p squared, as long as both c and p are not equal to 0. Alright, let's look at another example. Ooh, this looks like a harder one, but I'm sure we can do it. And you might be tempted to scream, oh look, I know how to do this. We divide over here, so we turn this into a multiplication, we switch this around. Very good, very good. Indeed, we can do that. But maybe, just maybe, there's something else we can do first. Notice all these big expressions. We can simplify those by factorizing like we did last lesson. So let's try if we can do that. X squared minus 9, you can write that as x plus 3 times x minus 3. Remember, x squared minus 3x plus 3x cancel out, minus 9. So indeed, x squared minus 9 can be written as this. And with a similar reasoning, the thing on the bottom can be written as a multiplication. And the multiplication, we're looking for two numbers that multiply to 3, and when we add them we get minus 4. Well, that would be minus 3 and minus 1. Let's do the next one while we're at it. 2x minus 2. You might say, I can't do the same, we don't have an x squared. That's true, that's true. But there's a common factor of 2 in there, isn't there? You can write this as 2 times x minus 1. Alright, what about the bottom? Again, a multiplication, two sets of brackets. We need two numbers that multiply to 6 and add up to 5. Well, that's 2, positive 2 and positive 3. And let's do two steps in one go, shall we? Division by a fraction is the same as multiplication by the opposite fraction. So we flip this one. So the bottom is now 6x instead of the top. What can we say about the top? Well, 2x squared plus 4x. What can you do with that? Well, I see... Oh, I know. There's a multiplying of 2 happening on both sides. And they both have an x in them. So we can take out the common factor of 2x, which leaves us with 2x times x makes 2x squared, and 2x times 2 makes 4x. Alright, now this looks like an even bigger mess than we started with, but something beautiful is about to happen. Because if you take a look, this x plus 3 is multiplied by x minus 2, is multiplied by 2, is multiplied by x minus 1, is multiplied by 2x, is multiplied by x plus 2. And on the bottom, x minus 3 is multiplied by x minus 1 is multiplied by x plus 2 is multiplied by x plus 3 is multiplied by 6x. There's a lot of multiplication happening here, and whenever there's a lot of multiplication happening in a fraction, have a look if you can maybe cross some parts out. Because this x plus 3 on the top is divided by this x plus 3 on the bottom, so they cancel each other out. The x minus 3 over here cancels out this one. These cancel each other out. And these cancel each other out. Which basically means that we are only left with 2 times 2x on top and 6x on the bottom, which works out to be 2 times 2 is 4. 4 divided by 6 is the same as 2 over 3. And x divided by x is just 1. So 2 over 3 times 1, just 2 over 3. So you might say, oh wow, we're done. Almost. Remember, this is also about restrictions on variables. So again, we have a look at the initial question. What values can x not take in this case? Well, remember, we can't be dividing by 0. So we have a look at these expressions on the bottom. And now, this is helpful. We already worked out the factorization. So since none of these can become 0, because otherwise we would be dividing by 0, we know that x minus 3 is not 0. Therefore, x cannot be 3. X minus 1 is not 0. So x cannot be 1. We also know that x plus 2 is not equal to 0. So x cannot be minus 2. X plus 3 is not 0. So x is not minus 3. 6x cannot be 0. So x is not 0 itself. And don't forget, this used to be division as well. So 2x is not 0, but we already covered that with 6x not being 0 because x is not 0. And x plus 2 is not equal to 0. We already covered that as well with this x is not equal to minus 2. So now we have found all of the cases that x cannot be. So therefore we have found our answer. X is equal, this entire expression is equal to 2/3. So this is your answer. But these are the constraints. I hope this helped you a bit and that you are able to continue your mathematics adventure now. See you in the next video. Bye bye.